Hello everyone, this is INE Foundation Lab 3 and section 6.1 Label Exchange. Okay, this section is about MPLS. Let me explain MPLS concept and I will come back and conclude this section. Okay, MPLS or multi-protocol label switching employs or uses two label distribution protocol. One is LDP or label distribution protocol and the other one is TDP or tag distribution protocol. LDP is a standard protocol defined by the IETF. Its primary purpose is to enable pre-label switch routers or LSR or P or provider. I will explain this LSR and P provider a little bit later. In an imperative to exchange label building information. LDP facilitates hop by hop forwarding by distributing label along normally routed path. When LSR communicates LDP parameters, they establish a label switch path or LSP, and the LDP session run over TCP port 646. And this is the default in Cisco devices. Cisco devices default to using LDP for label distribution. LDP is default in Cisco devices. TDP or tag distribution protocol. TDP is a Cisco proprietary label protocol based on the MPLS LDP standard. TDP is Cisco proprietary and LDP is standard, defined by IETF. This is the first difference between these two. And TDP allows the establishment and maintenance of routers based on labels, and unlike TDP, which is standardized, TDP is specific to Cisco devices. And TDP session operate over TCP port 711. Okay, let me explain LDP in more details. The label distribution protocol or LDP is a protocol defined by IETF for distributing labels in an MPLS environment. And here are some key points about LDP. LDP allows routers capable of MPLS to exchange label mapping information. It builds and maintains label switch path or LSP databases used for forwarding traffic to MPLS network. And LDP distributes both inner label or VPN service label and the other label or path label in MPLS. And for inner label distribution, targeted LDP is used. And LDP discovery runs on UDP port 646 and sessions are established on TCP port 646. Both discovery and session uses discovery uses UDP port 646 and session uses TCP port 646. And during discovery, hello packets are sent to the all routers on the subnet multicast address 224.0.0.2 for LDP, while TLDP or targeted LDP unicast allows packets to targeted neighbors. TLDP uses unicast hello packet, but LDP uses multicast address of this one for LDP. This is the difference between TLDP and LDP. Okay, LDP peering. In general, there are two primary ways to establish label distribution peering or LDP peering. One is basic discovery and the other one is extended discovery. These are two primary ways for establishing LDP peerings: basic discovery and extended discovery. Basic discovery. This method uses link hello messages sent to the multicast address of this is the same all routers on the subnet address 224.0.0.2. This is for basic discovery. These messages allows all directly connected labels, switch routers, LSI or provider routers on the subnet to discover each other and establish a hello discovery. Extended hello address, excuse me. And this basic discovery, this method is used with directly connected sessions. And if LSR or P or provider router is one hop from its neighbor, it is directly connected to this neighbor. This is one hop away from its neighbor. Another way to establish label distribution protocol peering is extended discovery. This method uses LDP targeted hello messages sent to a specific IP address. This uses TLDP or targeted LDP, which uses unicast. It uses unicast to send in specific IP addresses. This allows LSR to establish LDP session even if they are not directly connected. When LSR is more than one hop away, and then it uses extended discovery for LDP peering. And this method is used with targeted LDP session or TLDP and is used for routers which multiple hops away, more than one hop, and this extended discovery is used with MPLS TE scenarios. And if LSR P or provider router is more than one hop away from its neighbor, it is not directly connected to its neighbor. Then it uses extended discovery for LDP peerings. Okay, LDP discovery phase. In LDP discovery, LDP sends UDP multicast hello packets to the address of all routers on the subnet 224.0.0.2 on port 646. This hello packet helps in discovering other LDP neighbors on the same subnet. And the local interface's IP address is used as the source IP of the packet. This is LDP discovery phase. In LDP discovery, these three things will happen. The local interface IP address is used for source IP, and these hello packets help in discovering other LDP LDP neighbors on the same subnet and sends UDP multicast hello packets to this address, all routed on the same subnet address. The other phase is session establishment. First is LDP establishment is first uses discovery phase, then it uses session establishment phase. Once neighbors are discovered in discovery phase, LDP establishes TCP connection on port 646. This TCP connection is used to exchange LDP messages and build the neighbor adjacency. And the router ID is used as the source IP address, source IP of the TCP session. These things happens in session establishment phase. The router ID and the TCP connection function and LDP TCP connection on port 646. First discovery phase will happen, then session establishment. And in summary, UDP port 6. These are the things that happen. LDP uses UDP port 646, and it uses source IP address, the local interface IP address. It uses as source IP address of the packet. Then it uses multicast address of all routers, and allowing the hello packets to reach all potential LDP neighbors. Okay, LDP can be enabled by MPLS IP command on the interface configuration mode. And any interface that has the MPLS IP enabled will multicast the LDP hello packets. This is one way to enable MPLS by to enable LDP. To enable LDP, we can use MPLS IP command on the interface configuration. The other way we can enable LDP can be enabled on all interface in OSPF and ISIS routing protocols. On the OSPF process, we can use MPLS LDP autoconfig. This will make LDP autoconfiguration. LDP can be enabled on all interfaces in OSPF and ISIS by this command: MPLS LDP autoconfig. Okay, let's see another MPLS concept. One is LDP router ID, LSI ID, and LDP transport addresses. Okay, LDP router ID. LDP will use the router ID as the source of TCP session. This process happens in the session establishment phase. The router ID is used as source IP address of TCP session. First discovery phase happens, then session establishment. To modify the router ID, we can use MPLS LDP router ID interface first command. And by default, router ID is selected with the highest IP address of loopback. And if non-loopback exists, the highest IP of any active interface will become our LDP router ID. If there is no loopback, then it will choose highest IP address of any active interfaces or interfaces that are in no short state. The other one is LSI ID. The label switching router or LSI ID is a unique identifier for the LSR within a network, and it plays a crucial role in the operation of protocols like LDP. And here are some key points about LSI IDs. Its uniqueness. Each LSI in the network must have a unique LSI ID to avoid conflicts. The other one is router ID. The LSI ID is often the same as the router ID, which is typically the highest IP address on the router's active interfaces or mono-configured IP address. And the other one is its usage. The LSI ID is used as the source IP address of the TCP session in LDP, ensuring that each LSI can be uniquely identified during the session establishment. And LSI ID made of two components. The first 4 bytes called LDP router ID identify the LSI that owns the label space, and the last 2 bytes called the local label space ID identify the label space within the LSI. This is LSI concept two part. One is LDP router ID, and the other one is local label space ID. The other one is LDP transport address. The LDP transport address is crucial for establishing the TCP sessions between label switching router LSI or P or provider routers. And yeah, some key about this purpose. The transport address is used to identify the TCP session over which the LDP session will run. And this address is advertised in the hello packets during the discovery phase. This is the discovery phase. In the first phase of our LDP. The other one is selection. By default, the router ID. Often the loopback address is used as the transport address. And you can conquest specific IP address or interface to be used as the transport address. We can modify our transport address by this command: implements LDP discovery transport address interface command. This command is used this command is used for changing our transport address. And with MPLS, LDP, discovery transport, dash address, and specify our interface. Okay, let's in summary, there are two primary ways to establish one is basic discovery and extended discovery. Basic discovery is for LDP, and this is for LSI for 1 hop away, and extended discovery is for LSI more than 1 hop away. It uses TLDP, but basic discovery uses LDP, multi-cut address, and TDP uses multicast hello packets. And LDP, for LDP session establishment, there are two phases. One is discovery phase and the other one is session establishment phase. First, discovery phase must be happened, then session establishment phase. We have LDP router IDs, LSA IDs, and LDP transport addresses. Okay, let's see MPLS LDP label filtering. We can filter our labels. First, we have to disable advertising for our label. For label MPLS label filtering, first we have to disable advertisement for our label by this command: no MPLS LDP advertisement label. Then use access list to specify our network to our label. We create access list, number, permit, IP address, and mask to specify what network to our labels. Then we use MPLS LDP advertise label and specify our access list number. The number is the same number. This is how we can filter our labels. And we can also protect data between LDP peers with MD5 authentication. This is so easy. First, we use MPLS LDP password required command. Any peers that tries to form a session without authentication will be denied if we convert this. Then we specify MPLS LDP neighbor address, remote address, and password, and specify our password. This will make MD5 authentication between LDP peers. These two commands: first, password required, then specify our password between two LDP peers. This is how we can use MD5 authentication between our LDP peers. And let's see MPLS terminology. What is C as a in here? What is LSR, P, C, and P? Let's see what are this terminology means. Embedded label. Okay. Okay, MPLS terminology. Let's see what is C. PE. C means customer edge. PE means provider edge. PE also called area or label edge router, or it is also called ingress or egress LSR. These terminologies are used for PE routers. PE is the same as provider edge, same as area or label edge router, or it is also called ingress or egress LSR. C means customer edge, and the last one is P or provider, also called LSR or label switch router or switching router. Okay, let's see this terminology. I'll show this picture here. Okay. This is our forwarding path, this is our source, and this is our destination network. The packet is coming from source to destination. This is the way forwarding path. In an MPLS network, the first router in a MPLS network is called, if this is the way of path forwarding source from source to destination, this is called ingress LSR or area. This is also called P PE. This is our P router. Or area or ingress area. This is our it's called area or ingress LSR or P. Let's start with P. This P router is located on the edge of our service provider site. The edge router of our service provider's backbone network. This is where our P router is located in our MPLS network. It's located on edge of our service provider site. Performs both P routers or area or ingress LSRs. This is ingress LSR. Perform both IP lookups and MPLS label switching. IP lookup, when a P router receives a packet from a customer edge, this is customer edge router. When a P router receives a packet from customer edge, it performs an IP lookup to determine the appropriate MPLS label to assign to the packet based on the destination IP addresses. This is how IP lookup is working. And the other one is MPLS label switching. Once the packet is labeled, the P router forwards it to the MPLS network. And the MPLS labels are used to make forwarding decisions within the MPLS network, allowing for efficient and scalable routing. And this P router shouldn't be connected to P routers. This is P routers, and can be directly connected to each other. And area are the ingress or egress routers, or act as the entry and exit point of the MPLS network. An area push an MPLS label onto an incoming packet and pop it off an outgoing packet. Okay, this means area push an MPLS label onto an incoming packet and pop it off an outgoing packet. If you see, incoming ingress LSR are pushing packets, and egress LSR are popping the packet because they are located at the egress point of MPLS network. So P, this one is P either, and these are P or provider routers, and this one is a customer edge. Ingress LSRs or area push our packet, and egress LSR pop our packet. And PO provider router perform both IP lookup and MPLS label switching. Okay, let's see customer edge. Located on the customer side, this is our customer edge is located customer edge routers. These are routers that router at the edge of the customer network. They connect to the P routers in the service provider network. Customer edge router are always connected to our P routers. This is customer edge P, and customer edge router do not use MPLS or don't switch MPLS label, and do not perform MPLS label switching, and do not perform IP lookups for packets for MPLS VPN. And when a packet arrives at C routers, it is forwarded to P routers. Okay, C routers do not perform both IP lookup and MPLS label switching. And the last one is our P or LSR routers. P or LSR label switch router located in the middle of MPLS network or core routers of our service provider backbone network. P routers are located in our core MPLS provider backbone network, like here. Let me show. This is P routers or LSR, and connect to P routers and other P routers, and it's not connected to any C routers. And provider routers in MPLS network do not perform IP lookups. Instead, they focus on MPLS label switching. Okay, P routers do not perform IP lookup. They only switch a label. This is a swap. And MPLS label switching, P routers use the MPLS label to make forwarding decision. And when a label packet arrives at the P router, the router examines the label, swap it with the new label based on this label forwarding table, and forward the packet to the next hop. Okay, P routers do swapping. When a label arrives on P router, swap it with the new label based on its label forwarding table, and forward the packet to another next hop. This is this packet swap the label with new label, then forward it to another next hop. Return swap the label, then forward it to last router or P, then P will pop the label. Okay, we as I explained, there are three types of label. One is label push, swap, and pop. Push add the label to the packet. This is done by P. P will add the label, push the label. This is done by ingress LSR. Ingress LSR do push the label. It means add the label to the packet. This is done by ingress LSR. And we have label, replacing the label with another value. This is done by P or LSRs. And the other one is pop label, removing the label. This is done by egress LSR. It means push and this is bar done. Yes. Okay. Push, swap, and pop. The other concept is penultimate hop popping on PHP. This process is removing the outmost label of an MPLS packet by LSR or EGS LSR. Before the packet is passed to earlier. Excuse me, this is not bar. This is packet by LSR. This is P. Penultimate popping means is removing the outmost label of an MPLS packet by LSR or P. This is our P. Provider. Before the packet is passed to earlier, or this should be EGS LSR. It is the process by which the outmost label of targeted packet is removed by label switch router or P, LSR or P, before the packet is passed to the adjacent label edge router. Whenever this pop the label, this will become without popping. This is done by P. This is penultimate popping with done. Penultimate popping is done by this sorter, this PHP. Okay, and it is done with the implicit null label, and it has value of 3, and the implicit null label is advertised by LSR for all of its directly connected or some of the prefixes. And to verify our implicit null label, we can use show implicit LDP bindings, neighbor remove IP commands. Special neighbor and special remote IP on LSRs. On inside router, we can use show IP and LDP bindings neighbor remote IP to verify this implicit null label. And the other one is let's show another picture of this one. Now we can understand what is ingress LSR or area LSRs or P routers. There's another picture. This is another one. C PEP, or this is a backbone P routers, and this is another picture. We have CE forward IP packet. This is okay. This is down here. custom purple. This is RP. This is also called, where is this? Ingress LSR or LER. Ingress LSR, LER, and this is our P or LSR, our LSR routers, LSR, and this is egress. This one is egress LSR or LER. This is push. This is doing push the lever, and this is pop the lever. Because this P rotor is popping it will come without popping. The lever pop it. If this P is popping the lever, it will call without popping. Popping the lever before forwarding into area, egress area. Because here our provider is doing popping, it becomes PHP. Okay, this is PHP, and let's see MPLS table. This is our last concept of our MPLS network and command. Okay, the last part is MPLS tables. First is routing information based table or RIB. Let's show this picture here. It is our MPLS table. We have control panel and forwarding plane or data plane, control plane and data plane. RIB routing information table. Prefixes from other routers are stored in RIB or RIB. The information in the RIB is used to build the FIB or forward information base. We can verify or show our table with show upload command. This is our RIB, and this information is to build this FIB or forward information base table. Forward information base table, it is used for actual forwarding of our IP packet, and we can see this table by show IPsec command. These are our routing tables, and for MPLS, these are and this is our MPLS table. This is our routing. This is our MPLS table, LDP. We have LIB and LFIB for our MPLS tables. LIB, it is used to store labels for our prefixes. This is unequal for lib. This is lib. Store information for prefixes. Store in labels for our prefixes, and this information in lib is used for build the LFIB or label forwarding information base. This information is used for build this LFIB table. We can see this LIB table by this command show MPLS LIB bindings. This is equal to show IP route. And LFIB table, it is used for actual forwarding of a packet, and it is used for forwarding decision of packet within employer's label, with the position of packet with the employee label on it. And we can see this table by this command, show employer's forwarding table command. This is similar to show IP set in our routing. Okay, and for concurrent LDP, we can configure either by interface level or by auto configuration on the routing process OSPF or ISIS. And to verify our MPLS, we can, to see if LDP is enabled or not, we can use show MPLS interface, and to check if LDP enables. And to check our LDP neighbors, we can use show MPLS LDP neighbor, show MPLS LDP neighbor details, and to assign label to our label numbers, we can use MPLS label range. To take effect, it is required to reload the router to take effect. And to verify implicit null label on LSR, we can use show MPLS LDP bindings neighbor remote IP, and to see if our MPLS, MPLS interface in OSPF, we can use show IP OSPF MPLS label interface command. If we do auto, if we configure MPLS LDP auto config on the OSPF, we can also verify this by show IP OSPF MPLS LDP interface command. Okay, and let's configure this section. Okay, configure 1, 2, 3, 5, 6, and 7 for label exchange using IUTF. It means we have to use LDP instead of TDP. LDP is IETF, TDP is Cisco property. We have to use LDP and use previous number of commands to set up label exchange between the MPN routers. And authenticate the label exchange with password. It means we have to use the previous number of commands to set up label. It means we have to configure LDP auto configuration. It means because we have OSPF, let's see that topology here. We have OSPF between our VPN. This is our hub, R2 is hub, and the one to the other one is spoke. We have auto configuration. Okay, R2 is our DMVPN hub. Show DMVPN. Let's see. This is up. The other one is up either. OSPF is up, tunnel is up. Okay, this is up. RDMPN. Show IP NHRP multicast. We have this is our tunnel or spoke MBMA addresses. These are dynamically enabled. This is our hub. This is our spoke 1, 7 and to auto spot. Let's conquer enable label distribution ADP. Spot R1. We have OSPF show IP protocols. We have OSPF number 1, and this is our neighbor. With 2 tunnel and 2, 3, 7, 6. Okay, config. Go to OSPF 1 with iType MPLS ADP autoconfig. Let's start with 2 config T. This is the same as the auto SPF 1 and MPLS ADP autoconfig and T config T auto SPF 1 MPLS ADP autoconfig. Okay, on 5, because there is no OSPF on R5, we have ERGRP. I will enable MPLS on interface level on R5. Then we have OSPF for 2, 3, 7, and 6. Let's see 6 config T. Auto OSPF 1. I'm presenting with the config. And 7. On 7 we have to configure both autoconfig and MPLS interface level between 5 and 7. This interface. I will enable autoconfig for this router, this side of network, and MPLS IP between 5 and 7. Okay, config T. Auto OSPF 1. Autoconfig, and let's configure 5 and 7. Show IP interface brief between 5 and this interface. Config T interface this one and type MPLS IP. This is another way to enable MPLS labels. This MPLS IP autoconfig on us. push IP interface brief. This is the same interface here. One, two, three. Interface this one. MPLS IP. And between this is between 5 and 7, and there is another interface between 6 and 7. This network is done by autoconfig by tunnel, and there is another interface between 6 and 7. Interface MPLS IP less than 6 to show IP interface brief and this interface. Interface this one MPLS IP. And we have to authenticate label exchange with password of this one. Okay, let's before this I can set my LDP router ID. I can use MPLS router ID interface and false. I will set my LDP router IDs as loopback and compare this. Okay, let's do this. Exit. MPLS LDP router ID unspecified loopback. There I can specify false. Same as here. Five. Six. and 7. And now next authenticate. How to use authentication for MD5 authentication. I have to specify MPLS password required. And first I have to conquer this. This means has to form possession. Any page that has to without authentication will be denied. First I have to specify this command, then specify MPLS neighbor. Specify this is LDP neighbor ID will become a loopback because I have force I have this command. Now I have to use a loopback 0 of a remote. Okay, let's do to verify that you can verify if LDP is enabled or not. You can still show input interfaces and show input LDP neighbor. Okay, do show input interfaces and do show input LDP neighbor. Do show input neighbor. So neighbor. I have two number LDP ID net 3 and LDP ID net 66. I have forced because I have conquered this command and proceed with ID force. The neighbor address will become a loopback. Okay, now come for authentication. And proceed password required. Now label are done. Show me interface. Interface is done. No. This is the T hub. This is tunnel. I tunnel. This is T I hub. Then I have to specify neighbor. Then specify one interface with one neighbor with a tunnel. This is a tunnel. One is with tunnel hub. Let me show you this. Okay. On one neighbor with a hub. This is hub and this is spoke, and the other one with 6. This one up to neighbor. Okay, once the then I have to specify this command ampersand neighbor specify hub three password is LDP on the side. LDP underscore let's copy this one. Okay. And the other one is 666. And let's verify visual person interfaces, and yes. I have to confirm the other side either. One is 1 3. Neighbor is 1 1 1 1 1, and password is this one. Password. This one, and the other one is on 6. Implicit password required. Implicit LDP password required. And the person implicit neighbor. Remote address is 1 1 1 1, and password is this one. Password this one. And now let's verify R1 and R6. Show neighbor, and I have 2 neighbors up, and she's up here. Let's come on R2. And penalty password required. And then say LDP neighbor. For neighbor, R2 is only 1 neighbor. 3 to what up? 3 3 3 3 3. Password is this one. R2 only uses 1 neighbor here. Now T is let's conquer 7 and 3. Seven. Configure it. We have neighbor with 3 hub. Password is this one. Until you have to conquer 7 on 2. Three and 7 and 2. And then 7 I have to come for another neighbor with 5 and 6. Here I have conquered 3 neighbors on 3. One is toward 2, toward 7, and toward 1. On 7 I have to conquer another neighbor 1 for 6 and 1 for 7. 1 for 5. 1 for 6 and 1 for 5. Five and 6. And on 6 I have to configure for 7 either. And 5. Go to quiet and beside we neighbor password. It should be 7. This is the same. And 5. Okay, it's up. Okay, now let's put on our 5. Let's see. Show MPLS LDP maybe and detail command. And this is password required for use for between MD5. MD5 is on and it is password required. Okay, that's it. I hope you have enjoyed this video, and thank you for watching.